of you. I hope you are fine. Again, we are here for our next unit, that is vector, second part of the second unit. First, we have done about kinematics, beta. There is a motion in a straight line. Now, today we are here for doing our next part of the second unit, vector. Okay, what is the need of the vector? Better than initially before the vector, we have done all quantities in form of the scalar terms only. There are no need to do any direction. Okay, we are doing their distance, displacement. There we are reading only scalar terms only, about the mathematical value, magnitude only we are reading. Now we will do if having direction also with the magnitude, then what happened. Okay, then we will start our beta. Initially in first part we learned about the one dimension of the motion. Here motion is having three type of the motion, 1D, 2D and 3 dimension. And if there will be motion in one dimension only, then there will be one direction only. If direction can be changed, can be 2 dimension, can be 3 dimension. For understanding about the 2D and 3D motion, that's why we will read about the vector. Okay, now we are starting your vector and scalar. Scalar and vector, what is the difference between scalar and vector quantity? Then scalar quantity, those quantity which are having only the mathematical value, magnitude. Okay, we are calling it magnitude. For example, we are going from here to anywhere. Then if we are talking about this one, 10 kilometer, 12 kilometer, 20 kilometer, they are going here and there. Mathematical value, if we are talking about only the number only, then we will call it magnitude. Okay, and if we will define direction also with the magnitude, in which direction we are going there, then we will call it vector quantity. Okay, for example, here we are in the school, then another one is our home. Okay, this one school and your home, here we want to go from school to home, home to school, and our school distance is our, for example, your 10 kilometer. ओके, स्कूल से घर तक का जो आपका पाथ है वो कितना लंबा है, 10 किलोमीटर का लंबा है. ओके, अगर मैं ये कहूँ घर से मैं 10 किलोमीटर पे चली तो मैं क्या स्कूल पहुंच जाएंगे? यस और नो? बट 10 किलोमीटर वी आर नॉट टॉकिंग अबाउट द डायरेक्शन. हम 10 किलोमीटर है, their distance between them is 10 kilometer, but 10 kilometer beta, if we don't know the direction, can we reach school? क्योंकि 10 किलोमीटर तो हम चारों तरफ, घर के चारों तरफ कहीं भी चल सकते हैं. क्लियर? तो सिर्फ 10 क्या होगा हमारी स्केलर क्वांटिटी. अब 10 किलोमीटर स्कूल की डायरेक्शन अगर हम डिफाइन करें कि स्कूल कहाँ, डायरेक्शन कहाँ लाई कर रहा है, विद द डायरेक्शन ऑल्सो वी आर फॉलोइंग, देन वी विल कॉल दिस वन क्वांटिटी बिकम्स योर वेक्टर क्वांटिटी. व्हाट? वेक्टर क्वांटिटी. अंडरस्टूड कि 10 किलोमीटर हम किधर चल रहे हैं, किस डायरेक्शन में स्कूल है, then proper we are defining it with the direction plus magnitude, then we will call it vector quantity. Okay, so all the physical quantities we are dividing into two type of the quantities, scalar and vector. Tensor also having quantity beta, that is out of this scalar and vector, this one is not having in syllabus of 11th class. We will do scalar and vector, two type of the quantity we will do. Okay, so all are divided into two quantities only, scalar and can be vector. So those quantity which can be defined only magnitude, not having direction, then we will call it scalar quantity, and it is just a number. Okay, scalar is just a number, we can say mathematical value only, and its example are mass, time, speed, work, distance. These all are the example of the scalar quantity only. With help of this one we can define their magnitude, not any direction. Okay, next term your vector. Vector, in the vector we can define direction as well as the magnitude. Okay, here I told you beta, if we know about this one 10 kilometer, in which direction you want to go there, कि अगर आप घर से स्कूल जा रहे हैं, 10 किलोमीटर का डिस्टेंस है दोनों में, अगर 10 किलोमीटर का अगर हमें एग्जैक्ट डायरेक्शन पता है कि स्कूल उधर जाना है, तो वो क्या होगी आपकी वेक्टर क्वांटिटी. अगर आप 10 किलोमीटर ट्रैवल भी कर रहे हैं, बट इन नॉट इन अ वे कि किस डायरेक्शन में हम जा रहे हैं, 10 किलोमीटर आपने ट्रैवल किया बट बिना डायरेक्शन के, देन वी विल कॉल इट स्केलर क्वांटिटी. Okay, so vector having both magnitude as well as the direction, then we will call it vector quantity. Vector quantity example we can say displacement. Displacement already we have done about this one. Shortest path is known as displacement. Velocity already we have done. that is your displacement per unit time is known as velocity. So these are vector quantity, force and momentum we will do later on. These also example of the vector quantities. Okay, so see here one question, which of the following quantity is a not vector? Here these options are given, out of these we have to find out which are scalar or not scalar. Here we have to find not vector, means not having direction, only magnitude will be there. We have to find out this one. So force is our vector quantity, momentum also vector quantity, acceleration also, speed is our scalar quantity. So right option will be our speed only. Speed only will define magnitude, not having any direction, because it is a depend upon distance. Okay, and distance can be any path in any direction, not having any proper direction. That's why it will come in the category of the scalar quantity. Okay, so right option will be our D option. Now next will be our, if a bus is accelerating toward the north at the rate of the 3 meter per second square. Okay, this one our acceleration, meter per second square. With help of the SI unit you can identify what is this one, meter per second square is your acceleration. Okay, so that bus is accelerating toward the north direction. If direction will be given here in this question, proper direction is given of the body, north direction. So with the direction we can say it will be our vector quantity, not only defining their मैग्नीट्यूड ओनली. यहाँ पे सिर्फ 3 मीटर पर सेकंड मैग्नीट्यूड नहीं, यहाँ पे क्या है डायरेक्शन भी. दैट्स व्हाई वी विल कॉल इट वेक्टर क्वांटिटी. दिस सी एंड डी विल बी रॉन्ग ऑप्शन. ओके, understood now what is the meaning of the vector? Vector means which define the direction with the magnitude also. Okay, so how we can represent our vector? Vector, any quantity are vector or not vector, then what is the representation of the vector? Vector are representing graphically by the arrow with a head and tail. Okay, with this one arrow, like this one arrow is a symbol of any vector, we can represent with this one symbol, and this one arrow one side we will call it tail, and this one side we will call it head. Okay, which one having this one sign, that we will call it tail of the vector, and this one we will call it head of the vector. And length of the indicate magnitude, and arrowhead show the direction, means this one from here to there, then this one will represent the magnitude of any vector. Understood? This length of this one vector will represent magnitude of any vector, and this arrowhead, this arrow is a direction of your vector. For example, if we are drawing this one arrow in this direction, so direction of vector will be like this one. Okay, this one will be tail, this one will be head, and this one length we will call it magnitude of any vector. Okay, that is small length, large length. This one will explain the magnitude of vector, and this symbol will be explained direction. Okay, so here by using this one syntax we can write any vector quantity. For example, if we are writing here displacement, I told you that is vector quantity. Okay, let we are taking x as displacement, and that is we can represent this displacement in form of the vector, this one symbol. Okay, and here we can write there x1 I cap plus y1 j cap plus z1 k cap. Okay, this one is a representation of any vector. Here x1, y1, z1, these are the magnitude of the vector, means I, j, k. Here I cap, j cap, k cap, here indicating the direction. Beta I cap stands for x direction. Okay, j cap stands for y direction, and your z cap stands for your k cap stands for the z direction. Okay, having their three axes x, y and z. If any body is traveling along x-axis, then we will indicate with help of the I cap. Traveling some along y direction, then we will indicate j cap, and traveling along the z direction, then we will use their k cap. Okay, so these are the unit vector which we are using there for the direction of any vector. Okay, so x, y1, z1, these are indicating the magnitude. along your I cap, j cap, k cap respectively. Okay, so this one is our vector term. Like this one we can write their equation of any vector quantity. Okay, so here ax, y, az, here this one are the component along your yx, yz axis respectively. So like this one we can represent any vector quantity is there. For example, force is our vector quantity, yes or no? Okay, so in vector form we can write there 2 I cap plus 4 j cap and minus 3 k cap. That will be Newton only. So like this one we can represent any vector quantity. Clear? Next will be a different term related to vector. Like this one, zero vector. What is zero vector? Those vector in which having zero magnitude, not having any direction. Okay, those vector we will call it zero, which are having zero magnitude and not having any direction. So position vector that represent the position of any point relative to the origin. Okay, like here we are taking x, y and here z. X, y and z. Okay, then from the origin, what is the position of this one point? Here we will represent with help of the position vector. Okay, here from here let this one x1, here y1. So along this one we can write there I cap plus here y1 j cap. Like this one we will represent those vector that we will call it position vector. Okay, next our equal vector. Those vector will be equal which are having same magnitude as well as the same direction, but their condition both should be physical quantity will be remain same only. Okay, for example, one force is this one there, another force also this one, both should be having same magnitude. Magnitude means with help of this one length we can define this one length of this one. So with help of this length we can define same magnitude, and direction also should be same in same direction, then we will call it equal vector. Okay, if one vector is acting in this direction, second vector is acting in this direction, then we will not call it equal vector. These are not equal vector. Okay, so these are equal vector which are having same magnitude and same direction. Next here negative vector. Negative vector, that is vector in which magnitude and same but direction is opposite with each other. Okay, here we discussed about this one. One vector is acting in this direction, let this one a vector, another vector acting in this direction. Both are having same magnitude but direction are opposite. Okay, direction are opposite, then we will call it negative vector. Okay, next term will be there beta, how we can find magnitude of any vector. Okay, any vector will be given. If we are talking about the vector in two dimension, then acting along x-axis and y-axis, then magnitude how we can find like this one. Okay, these are the symbol of the magnitude of any vector. Then here we will take under root, then ax square plus here a y square. This one is a indicate their magnitude of any two vector. Okay, this one is a magnitude of the 3D vector. Vector a, if we are writing like this one, then magnitude of this one vector will be like this one. For example, if your vector is this one, we are taking it for example, your vector x equal to your 2i cap minus 3j cap plus your 1k cap. Okay, like this one your vector we are taking there. Okay, then find here magnitude. What? Find magnitude of x vector. So how we can find? Apply this one formula beta. If 3D is there, then apply this one. If 2D is there, then apply this one. So how we can find this one here? Of this one magnitude, we will write there x magnitude under root. Okay, component along x-axis square of this one plus component acting along your y-axis, then here minus if there, then we will include in this one only. Okay, and here we will take square of this one plus here 1, then here we will take square of 1 only. Okay, now we will solve it under root 2 to the 4 plus 9 plus here 1. Okay, then here we can solve it, then it will give you 14 only under root 14. Then this is the magnitude of this quantity. this vector. Okay, like this one we can find with a magnitude of any vector. Magnitude means mathematical quantity of any vector terms. Okay, net value. So after this one, your unit vector. What is a unit vector? Unit vector, beta, those vector which are having magnitude 1 only and which are used for the indicating direction of any vector. Here we are using their I cap, j cap, I cap, j cap, k cap. These are the unit vector. Their magnitude is 1 only and they are using for the indicating direction. Okay, symbol of this one, symbol of unit vector will be this one cap. Okay, if anywhere we are writing this cap of any quantity, that means this is the unit vector of that quantity. Okay, so here f we are writing there, that means unit vector of this one. This one cap is a symbol of the unit vector. So magnitude of any unit vector always will be 1 only and used to indicate the direction only. Okay, so here formula of any unit vector will be equal to a vector, downside will be magnitude of that vector. For example, this question only we are taking here, x is equal to this one, then magnitude of this vector will be equal to this one. Okay, if you want to find out unit vector of this vector only, so how we can write there a cap, sorry, here we are writing there x now. X we have taken, x only this one vector. So unit vector of this one x we can write there x vector divided by your magnitude of x. Okay, so how we can write there, this one your x vector value is given here, this only, this is the vector 2i cap minus your 3j cap plus your k cap. Okay, downside we will write magnitude of this one, magnitude solved already, that is here under root 14. Okay, later you can solve it, otherwise you will leave it, then it is the indicating unit vector of any vector. Like this one we can find their magnitude of any vector and this one is a unit vector of any vector. Okay, now next will be there, if this one question we are taking there, then here we have to find out magnitude and unit vector. Okay, so how we can find beta, then here told you any vector will be there, then magnitude of this one vector, how we can find, this is the symbol of the magnitude of any vector. You can write these two lines and you can leave it, then it will indicate only magnitude. So here we will take under root, then component acting along x-axis, that is given your 3 only, square of this one component, plus component acting along your y-axis given -2. So write here -2 square. Then component along your z-axis here given 1, then square of this one, then we will take 1 only. Then so then here will be 9 plus 4 plus 1, then it will become here 14 only. After this one we are taking their unit vector, then apply this one unit vector. Okay, I told you symbol of this one cap if we are using, then this one indicate having unit vector. So use their formula, then a cap by a magnitude. A vector is given this one 3i cap minus 2j cap plus your k cap only, and downside we are writing 14 only. Okay, so like this one we can find the unit vector. Thank you for today. Then we will stop now only. Next topic we will do in next class.